This month, we use a ruler and do some flexing. Since it's now winter in the Great White North of Canada, we decided to revive an old ski boot. This is the good side. It still has its ratchet strap attached, but the ladder part of the strap broke on the other boot. This is a really important piece because it locks you into the boot and essentially handles all the power transfer to your skis. To start, we're going to remove the good strap and take a bunch of measurements so we can create our 3D file to print its replacement for the other side. It's a really simple assembly. We have this washer, a middle screw, and of course the strap itself. So let's get this boot out of the way and we'll take some measurements to build our file from. All our measurements only need to be precise enough to work. We're not trying to win any reverse engineering awards, so the overall length we'll say will be about 250 millimeters, and then we're not going to make a perfect recreation as I just mentioned, so we're going to make that hole probably about 8 millimeters. The space for the washer will round up to 20. We're just going to give ourselves a little extra breathing room. We'll make the width of the strap itself about 24-ish. The most important parts for this are going to be the teeth themselves. For spacing, we're looking around 5.5 millimeters, and then we need the height, which is about 4.25-ish. And that's all we need. We're not going to measure out this part where it winds a little bit. We want it to print really easy and flat in this orientation here so that our layers are going and stacking in this direction. That's going to give us a lot more durability, and it's also going to form the teeth a lot better than if we printed in this orientation where we would stack the teeth up, we wouldn't have as much definition, and we essentially have a shear plane right on the parts of the teeth where we need it to be strongest, so all the force could potentially just knock all the tops of the teeth off the straps and make it useless. Talking about precision again, if you look down where the strap engages with the ratchet, there's a little bit of daylight in there, so we're not going, once again, making it perfect, we're just making it work. You can see that in our Fusion 360 model. Really simple, lots of straight lines, flat, making it real easy to print. We know the technology we're using, we know how to create for it, and we're going to make it as easy on ourselves as possible. We have a saying around here, it should take 20% of the time to develop an idea 80% of the way, and that's where we answer all the questions and decide whether it's worth putting in the other 80% of the time to perfect it or go back to the drawing board and find a better way. Now that we have our piece out, we'll do a quick dry run before assembling it all together, making sure the ratchet works, the teeth are engaging in the right spots. Give it a little tug. Can't really see, I tried to make it so that you could, but we have about the same air gap as the stock strap. So with that test complete and generally a success, we'll reassemble everything and we'll give it a bit more of a test and see how well it holds. I'll actually put the ski boot on my foot. Since it's around Christmas time, we got a little extra weight. We're going to put 235 pounds into flexing this boot forward. We'll see if we can make the strap pop at all. Now for those ski nerds in the audience, I got a quick tidbit while I buckle everything up. These boots have actually made a hybrid of my Del Bello Krypton Il Moros and my full tilt boots that I had prior. I really like the flex pattern on the full tilt tongues, and I found that they attach exactly the same as Del Bello tongues do, so you can do a clean swap across and there's no issue. This is full body weight going into flexing on that strap. Did not slip any teeth. And I forgot to mention earlier, the material we used for this was Tallman Alloy 910. That PET nylon blend is amazing for applications like this, and it actually stood up really well to the cold when we tested this out in the real world.